Right. Okay, I think we should need to press on. I'm James Barlow. I'm a Professor of Technology and Innovation Management in the Business School, and along with Bob Shorten, I was one of the co-founders of CSEP and involved right at the early days in just getting it all set up. And one of the early sectors that we really felt we ought to be looking at was aerospace and aviation. Given the size in the UK economy, anything between 100 and 250,000 jobs, depending on how you define it, average 40% higher pay than other sectors, anything between about 9 and 25 billion pounds of gross value added every year. So clearly a major sector, hard to define what it is. But we have two reports coming out. First one imminently, led by Professor Rafael Palacios, and second one next year, led by Professor Laura Mainini. So I'm really delighted that we've got a great panel this morning to dig a little bit into the complexities of change within aviation / aerospace in the UK. And of course, the UK doesn't sit in a vacuum. It's part of a global industry, and I'm delighted that we have representatives from, I suppose, two sides of the sharp end of aerospace. Jim Albaugh from Boeing. Jim was formerly president and chief executive of Boeing Commercial, and obviously has vast insight from the perspective of one of the two main incumbents in the industry. And then Mark Higson is the chief operating officer for a really innovative startup who's going to be talking about his perspectives from the company's vertical aerospace, from the sort of world of air taxis, and a completely new industry. So we're going to kick off with Rafa, who will give us a little bit of background and insight from the first report, which is coming out, and then I'll turn to the panel for comments. Okay. So Rafa, over to you.
Ready to go. Good morning, everyone. So Rafael Palacios, head of department in Aeronautics. You already did the introduction, and probably I don't need to introduce the aerospace industry. I guess I have a question for you. Who took 3 return flights over the last 12 months in the audience? Okay, you know the average in the UK is less than 1. And that's part of the challenge on the aerospace sector. It's very unequal at the point of use. But on the point of production, which is where we're sitting, manufacturing is one of the cornerstones of the UK industry. I just put some numbers, so depending on how you look at it, if you count people working on airports, etc., it's almost 500,000 people working across the broad aerospace aviation sector in the UK. 70% of it is sport, and it's not just the fact that we produce a product, is that product has a use which is basically on the fiber of the economy and activities we do, and the fact that people like me are studying abroad and so on and so forth. And again, you already said that it's very high skilled industry. What are the challenges to this sector? Well, the most obvious one is that we have a commitment as society to go to net zero, and aviation doesn't have an easy answer. Okay, the current discussion is about the availability or lack of it of sustainable aviation fuels, and there's going to be a huge discussion on how this happens. So we need solutions there. There is another element to this, which is getting a new product on the market, and probably we'll discuss this later, is very, very costly and has a lot of regulation into it. So it's not an industry which is going to easily adopt innovation. So it has to go through many layers of analysis before it gets to the point. New airplanes are launched decades apart. And in terms of skills, that's a major challenge. The people that work on the last Boeing plane that probably retire the next Boeing plane is coming on board. And finally, from the point of view of the UK, it's a global sector. Okay, the industrial policy in the UK will have relatively, it's going to be constrained by what everyone is doing. You don't fly planes within the UK very rarely. So by definition, any solution, it has to be a solution which is adopted globally. And the production, even the manufacturing, has to respond to needs, not just in the UK, but policies which are, as I say, very far away from the UK. Now, what of this becomes kind of specific to the UK? Well, if we're looking into solutions to new fuels, the UK may not be the best place for those because we don't have the energy nor we have the biomass, which are the two requirements for it. It might be part of the answer, but not necessarily that has to be an industry which has the scaling done in the UK. We're talking about new companies and going innovation. We already discussed on the previous panel. Capital is typically a challenge for anything in the UK. New airplanes are decided at the headquarters of the new airplane or the large OEMs, the manufacturing companies, and none of those are in the UK. So we rely on decisions taken elsewhere, and being tier one is important, but the decision is going to be always in how we position the UK aerospace sector within a landscape in which decisions are taken elsewhere as well. And that goes on the last point. So anything that has to be thought on aerospace for the UK has to be thought basically as a sport market beyond what it actually has an impact locally. So that was part of the discussion we had when we were building the report, and I just put a few items here. So the first is that I'm going to make the distinction, which is not always done, between net zero aviation. Net zero aviation is aviation on hydrocarbon-based fuel, so they produce carbon, but then you deal with it, okay? And that's kind of where we are right now in terms of technology and the sort of things we can do. And the other is zero carbon aviation, which is, call it the future. Aviation built on alternative energy carriers, which are not based on hydrocarbons. We don't have those right now at the scale we need, but as a country, is that technology which is coming, and we should be taking part of this. So on the net zero, we went through the 4 levers that the aerospace sector has already identified the classics, and then we ranked in terms of where we can have the highest opportunities from the UK point of view. The first one is anything that has to do with operations, airplanes that exist or airplanes which are coming online, and in particular there is a kind of a huge element if the target is net zero, which is actually accounting for what is the impact of aviation on the environment, and a lot of it is not on the carbon itself. You might have heard of contrails, and you haven't heard of contrail, you should. A lot of it is on contrails, which is another greenhouse gas coming out of airplanes, which has as much effect as carbon. There's uncertainty, but the uncertainty doesn't take away that it's huge. Okay, and this is something which we could start acting right now. There is basically economy and a market which will be developing around this, and there's already a lot of strength in the UK for this. On the aerospace or manufacturing side of things, of course, we should aim to go fuel efficient on any direction of travel, okay? And this is because, as I said before, decisions taken elsewhere, so we need UK companies to be the tier one supplier when the next airplane comes online, okay? And for that you have to have the technology advance. SAF, or sustainable aviation fuels, any actions there should be to reduce costs in R&D. It's at a fundamental level. That's what we are. We are not at the scaling level. We're still at a point in which we need to make this actually to be a cost-competitive solution. And the final level is, if we want to get net zero, we will need to integrate carbon capture and storage, carbon markets, intrinsically into the aviation sector. The other part of the equation is zero carbon. That would mostly the second report. So I won't talk much on this one, but this is how we build hydrogen and electric aviation into the future. That's at the level of fundamental technologies. We need to make sure that this is embedded on the ecosystem. Finally, I should talk about the skills. Okay, the skills on the aerospace community by definition are high because that's what defines a high-tech area. But what we need is for the workforce that plans the next launch airplane on the 2035 to be digital ready in every possible sense. Okay, that's what the opportunity is in terms of retraining the workforce that exists on the aerospace sector. And with this I finish. I'll pass on to you. And
thanks, Rafael.
Thank you.
Good. Okay, so well, I'd like to really kick off with Mark. As I said, you're at the sharp end. You're developing a new type of aircraft, a new class of aircraft. You're doing it in the UK. You're faced with all the challenges that Rafael's just outlined, whether they're at a global scale or domestic ones. Perhaps we can just kick off with you telling us a little about little bit about vertical aerospace and really how you see the world from your perspective and the challenges in going through the whole process of R&D and bringing it to market.
Okay, thank you. Yeah, it's challenging, but it's also incredibly exciting. So that's probably the first start point. So Vertical Aerospace is a startup. We're pre-revenue. We're developing a 4-passenger electric aeroplane, which takes off like a helicopter and then flies like a plane. And that means that we can operate from small airfields, or not airfields, but landing pads. And we see this as a way of revolutionizing air mobility, making it easy for people to move short distances very quickly over traffic, etc., and within built-up areas. And that will take me on to regulation in a moment. The aircraft itself is innovative. It has an electric powertrain, which is new for certified passenger carrying aircraft. We're developing our own battery technology. We're using quite sophisticated control systems, and we also have some quite clever and innovative mechanisms to convert from vertical flight to horizontal flight by tilting the rotors on the wings. And at this point, we're at a very, very exciting stage where we're just flying the first prototypes. You'll see some videos all over social media of our test flights. And we're finalizing the design of our certification aircraft. So challenges on a number of fronts. I mean, clearly there's a need to raise money. And most of our money comes from capital markets. And that depends on our credibility and our technical progress, as well as the contacts that we can make. And we are in intensive contact with government, talking about the fact that this is a British startup. It's also, we have a lot of British partners supplying us. So it's a great innovation for Britain. As I said, most of our finance will come from capital markets, but we are accessing government funding through ATI for development. And without going into specifics, we're talking about assistance to help us industrialize. And that partnership between government and the private sector is the one that will make us successful. If I can just touch briefly on regulation, a very interesting characteristic of this sector is that the European and UK regulators have agreed a regulatory standard which is higher than the FAA have mandated in the US. And in fact, it's the same standard as commercial airliners. We see that as a positive rather than a negative, because clearly it drives us to go to a higher technical standard. It's obviously better for the customers and, more importantly, for the end users. And it means that the transferability of our aircraft from one regulatory zone to another is more straightforward. But it's obviously technically challenging. Final comments on that would be, I guess, two things. One is that we do need regulatory certainty. If that changed, that would be quite difficult for us. And the critical factor of it is that it allows us to fly passengers over built-up areas. Our aircraft will therefore be more competitive than anything used to the other standard. And the second point is really close working relationship with the regulatory authorities. We are in daily contact with the regulator on what is required and how we can prove our designs.
That's at a UK level, is it?
No,
or is that at a European level?
It's at a European level. Right. So there's a tripartite partnership really on this issue between the CAA, EASA in Europe, and ourselves. I mean, very close contact.
As I said, I think this, to some extent, is uncharted territory for this type of aircraft. Do you think there's an opportunity here for Europe / the UK to develop some sort of regulatory advantage here. We can set the standards to some extent.
Well, I think that's what we're doing. And I think that the fact that the CAA and EASA are working closely together, there's no distinction between what they are asking for, means that there is a coherent European position, which means, as I say, that we can fly in Europe in a way that lower certified aircraft will not be able to do, and we can export potentially to other areas with a less onerous transfer process.
Okay, Jim, I just want to turn to you for your perspective from many years in Boeing, but also from the other side of the Atlantic. And I guess the question really is, how do you see the UK aerospace sector? Notwithstanding the innovators like Mark, is Rolls-Royce the only game in town here, or?
No, I don't think it's only Rolls-Royce. If you look at the UK, I mean, the heritage here is terrific. You invented the jet engine. The Comet was the first commercial jet airplane. The Typhoon. You've done a lot of things over here over the years. I do think, though, the crown jewel is Rolls-Royce. And they're disadvantaged because they don't have a position on any of the single-aisle airplanes. And most of the engines go on single-aisle airplanes. And the money from the engine companies are made not by selling an engine, it's made doing the maintenance. And so there's not a maintenance base for Rolls-Royce. I think the good news is there are really only three competitors in the game: GE, Pratt, and then Rolls. And Rolls is working on a very innovative engine right now. It's called the UltraFan. We won't do a design review on it right here, but based on what I've seen, it certainly has great promise. Airlines are not going to buy an airplane that only gets a 10% improvement in fuel because the airplane is going to cost more than the present one they have. I think they will buy an airplane that has a 25% improvement in fuel burn. And that's what I think the UltraFan that Rolls is working on can get. So I think what we need to make sure it happens here, and I'm talking from a Boeing standpoint and also from a Airbus standpoint, we want to see that engine be successful. But I think it's going to require some government help to make that happen. One can look at China, and they have a very heavily subsidized aerospace business. France over time subsidized Airbus, and they developed an airplane that's on par with anything that Boeing does. And in the United States, we get indirect subsidies from NASA and also indirect subsidies from the Department of Defense. For instance, the Pratt & Whitney F-35 engine, the core of that engine was the one that they leveraged into the geared turbofan engine. So I think that Rolls was probably going to need a little assistance on the way to get that engine qualified, certified. And at the same time, I think Rolls needs to work very closely with both Boeing and Airbus, who haven't announced a new airplane, and my guess won't do a new airplane for another 5 to 7 years. But when they do, they're going to need a significant improvement in fuel burn, which I think the Rolls engine can provide.
I mean, from a Rolls-Royce perspective, this is a high risk, but potentially high reward bet they've got to make. So is the government role really in taking some of the risk out, so de-risking some of the development process? Yeah. And I guess the same question applies to Mark as well.
Yeah. Well, I think if Rolls doesn't get on a new small airplane, I think their years may be numbered in terms of how long they're going to be viable. You really have to have a position on an airplane where they're building 800 a year versus large airplanes where they're building maybe 200 a year.
I want to turn to the costs and I guess regulation as well in a bit more detail here. And I mean, we all know how incredibly expensive it is to bring a new aircraft to market. The timescales are massive. Part of that is in the R&D and certification. But how do we take cost out of the development process for aircraft? And I'm leading on to a question about AI here, really. And I'll bring Lara in a second. But when we were talking the other day, Jim, you were talking about the potential of AI to take costs both out of the R&D process through modelling, simulation, virtual
Yeah.
testing, and so on, but also regulation as well. And let's just give me your thoughts again
Well,
from the Boeing perspective, and Mark as well.
I won't
mean,
tell you
well,
how
I'll tell
expensive
you.
the 787 was to develop, but it was a big number, a really big number. In fact, there are countries whose budget for defense is much, much less than we spent on the 787. And I think one of the reasons that Airbus and Boeing are giving pause right now to a new airplane is because the development costs that they see are so high. And so they're looking at how do they take costs out. And, I look at Boeing and look at the fact that they're $53 billion in debt right now. They need to pay down that debt before they take on a new airplane. So how do they do that? Obviously they got to get up and rate on the 737 because that pays most of the bills at the Boeing company. But they can take, I think, huge amounts of cost out of production using AI. Program management and meeting all the requirements the FAA has is a lot of administrative work. And there are specs, there's planning and scheduling, there's documentation. There's a whole raft of things that require documentation, and I'll call it busy work. And I see, and I'm no expert on AI, I'll leave that to my colleagues here, but I see AI as in a way, as a summer intern. You give them the busy work, right? So those of you who have been a summer intern, you know that. But every day that summer intern gets smarter and smarter and smarter. And I think that we can take a large part of the cost of building an airplane out by using smart and intelligent agents. And with that money, you pay down the debt at the Boeing company, and then you can turn those AI agents loose on the design. And in theory, AI ought to be able to go through dozens, if not hundreds or thousands of design iterations using different assumptions to come up with the optimal build for the airplane. And in software, 787, we had 6 or 7 different software drops before we got it right. With AI, you ought to be able to get it done, I think, 1 or 2. And then the flight test program for a new airplane is very extensive, but if you could build a digital twin where you could in effect do your flight testing on the ground as opposed to flying every day like we did on the 787, you could take I think a lot of cost out. So I think it has great promise. And I think if one looks at and it was noted earlier, the people that worked on the 787, it flew for the first time in 2009. Here we are 16 years later, and many of the people have retired. But I think through AI, we can recover some of that knowledge and apply it to the build of a new airplane.
I'm already getting signals, time's coming up. But I do want to turn to Laura. You're a professor of computational design. This is your area.
Yes.
Give us your thoughts on how we shave cost out of R&D, design, development.
So this is a huge topic. So we'll try to go down a little bit to some key elements. So it's definitely true that there has a huge opportunities when it comes to computational science and engineering to accelerate and to reduce costs actually at all stages of the product life cycle. So from the design and development to the operation, manufacturing operations, maintenance, and even the commissioning. And yet we have, when it comes in particular to this period in time when we are looking into new concept, we've been mentioning before, right? New energy carriers to be used means new concept and aircraft. That means you cannot retrofit what you have. So there is some derivative experience that you cannot leverage. So you need to explore again. You need to model, investigate the physics, go down to the modeling and computational science and applied physics. So when we are talking about artificial intelligence, we are talking about learning from observation, from data. But if you don't have the new concept, you don't have those observations. So you need first to understand what is behind that. But when it comes to the use of AI, so learning from observations with the current generations of aircraft, from historical data of the different fleets that are operating, that's extremely useful. We have now the chance to put sensor pretty much everywhere. You can sensorize everything, and those are data that you can use. And yet, when we talk about aerospace and aeronautics, we are talking about a sector where learning from data and observation is different from social media. So your algorithm is not telling you which is the most suitable shoes you want to buy. It is telling you whether you have to, and this is why we're not there yet, pull up or turn in a certain way. So when it comes to machine learning in aerospace, we're getting into the world of so-called safety critical decision making, safety critical scenarios, high regret decision making. And that's why aerospace poses a very key open questions for development of next generation's AI where it comes to reliability characterizations, robustness characterization that even the most advanced algorithm of deep learning you're using now cannot provide. So aerospace sectors is posing questions in that area that can definitely accelerate the development and the introduction of novel technology and their integrations, their maintenance process. But there is the need also to invest in that R&D area.
You may not be able to answer this, but does the UK have any presence in AI companies specialising in this sector? We do in biopharma now, and that's beginning to make a difference in biopharma R&D. Do we see UK companies in this area?
There is definitely a leadership when it comes to academic research in that area. And it is translated into a new talent that is hired by the aerospace companies in the field of data analytics, data science, data-informed design, AI-enhanced design, you name it. So there is this huge engine potential that needs to be translated probably more effectively and also boosted a little bit more at the source of the development.
Okay, so familiar story from a UK perspective. Good at the science. Conscious of time, and I really just want to ask one last question and then one from the audience perhaps. And I think it'd be remiss of me not to just go back to the SAF issue. And I mean, there's a piece in the FT 3 or 4 days ago which basically said governments are giving up on the green transition and aviation. It's just too difficult. We'll let other industries take the load. But very quickly, really, and maybe Rafa, what's your perspective on really where we are going in that transition, and will we have different approaches in different parts of the world, different markets?
I think it's simply a matter of time scales. Okay, we have the technology time scale, the fact that we have to talk about airplanes which are flying 2035, you launch it, and all these technologies take a very long time. The political cycle works at a totally different phase. So maintaining the interest over a long period on any of our fields is going to be an issue no matter what we look into it. So I guess there are two things. One is that they are going to be the push of history. So we'll get there. We just don't know how. And the other is the fact that, of course, those of us which are the cold phase, we don't need to take the eye off the target. So, of course, the fundamentals are there. The research has to be there. We need to work on the problems which are important. We need to make sure that there is support for those, that there is sort of a long-term strategy in the level of what we need to build those technologies. And that is not going to be done by public acceptance at this stage. It has to be done at the fundamental level. This is the technology journey.
Okay, I think we're going to have to stop, and you'll have to reserve any questions for the break. Apart from our panel, we also have Sergei Kravchenko over there, who's visiting professor at Imperial, also working on this, and Hairie is somewhere.
Is there.
Is a researcher working on the project as well. So, thanks everybody, and I think we need to hand over to health tech, isn't it? No, yeah. Okay.